This is Module 9, Lesson 3. And what we're going to do is we're going to tie together all of these mole things that we've learned about. At this point, we learned in Lesson 1 that you could find the number of particles in a mole of something simply by using the number 6.02 times 10 to the 23rd. Then we learned how to calculate the mass of a mole and the volume of a mole in Lesson 2. So what we're going to see is that if mole goes right here in the middle, we've learned 3 things about it. So first, we learned how to find the number of representatives. This could have been atoms, be molecules, or this could be formula units. We learned that there's 6.02 times 10 to the 23rd of any of these in a mole. And then, like I said, we learned about molar mass, and we learned volume of sorry, let me step to do that. The volume of gas. Now, what we're going to do this time, we're going to try to make one of these outside areas to another one. So in other words, we might want to convert the number of molecules of something to the mass of that thing. Now, what you see by looking at this, I kind of think of it as a road map, is that there's no road that goes directly from particles to molar mass. Like, that doesn't exist. But what we can do is we can go from particles to mole, and then once we're at mole, we can go from mole to mass, or we could go from mole to volume. So the thing to keep in mind is that you need to get to mole. These are mole problems after all. So on your notes and practice page, which you're going to need at this point, you don't have to, but it would be helpful to you, as I have some example problems about doing these types of conversions. And the first one is this one. How many grams of KCl are in this many formula units of it? So our steps are the same as they were before. We're going to write down what we're given. We've got that many formula units of KCl. And then we're going to start converting. Keep in mind, our mission was get to mole and then get to the other thing. So can I go from formula units to mole? I can. That's the very first learn to do. So I can relate formula units of KCl to mole of KCl. We know that there are 6.02 times 10 to the 23rd formula units of anything in a mole. Now, another way that you can say this is you can also call this Avogadro's number. Avogadro's number is the 6.02 times 10 to the 23rd. So you could say that there's Avogadro's number in a mole. It's listed that way on your reference table too. It says Avogadro's number. Now, at this rate, formula units cancels, and I'm left with mole, which is not what it's asking for. It's asking grams. Well, I can from moles to grams. That's what we did in our last lesson. Sorry. So 1 mole of KCl would have 74.6 grams. How did I get this? I used my reference table and I added up the mass of a K and the mass of 1 Cl. I'm still asking you to round to 1 decimal place. That way we come up with the same answers. Okay, now remember about sig figs. None of this stuff counts because this is all reference table material. I'm just looking at this. This has 2 sig figs. So my answer calculator says 5.576. You don't have to write all of this down. I'm just doing it so we can discuss it. I get to keep the first 2 digits. It'll have 2 sig figs. The 7 is going on that 5 up. So that'll be 5.6. And over here, I should put the moles of KCl cancel. I'm left with grams of KCl. So that'll be my unit. 5.6 KCl. Okay. The second problem that I have is how many liters are in this many grams of carbon dioxide. So yet again, we start with what we're given, and I write the formula down. Now, you should be able to turn names into proper formulas at this point. Well, actually, yes, because the next thing that I'm going to do is calculate the number of grams of this, and if I don't write the formula correctly, then I'm not going to come up with the proper mass. So I'm going to go from grams of CO2 to moles of CO2. 1 mole of CO2 will have 40 grams using the periodic table. Okay, grams of CO2 cancels, and I'm at moles. Why did I go to moles? Because I can't go from grams to liters. I've just told you that these are mole problems. We've got to get to mole. Well, I can go from mole to liters because we've practiced this before. CO2 is a gas, and so we're going to assume that it's at STP. It doesn't say it is. There would be 22.4 liters per 1 mole. Moles of CO2 cancel. My calculator this. Now, the reason I put the ... is because I just want to talk about this number. I wrote down more digits than I know we're going to need, and that just means to me that there's more on here. There's more on my calculator screen. None of this counts in terms of the sig figs, but there's 3 sig figs right here, so I get to keep the 2, the 8, and the 8. The side of it's going to round it up. So 28.9, and then right here's my units that aren't marked out, liters of CO2. Okay? All right. One last example. Molecules are in this many of oxygen. You know what we're doing? We're starting with our given. Now, oxygen is O2, and this is going to come up in your problems. Remembering you about Brinkelhoff. Brinkelhoff is a saying that helps us remember the 7 elements that are diatomic: B, R, I, N, C, L, H, O, and F. So this is what it means. Like when it says oxygen, it doesn't mean just O, it means O2. If it said of bromine, then we'd write Br2. All of these always get written diatomically if they are alone by themselves, pure, whatever they are. So what does matter in this problem? Actually, unless they're asking us for math somewhere along the way, no, it's not going to get me in this problem, but I have problems in your practice where it will get us if we forget off. So for this one, we're going to liters, and then from liters to moles. So oxygen is a gas. We're going to assume that it's at STP, so there's 22.4 liters of oxygen in a mole. How did I know to go to mole? Because again, they're mole problems, and I can't get from liters to molecules, so I can memorize get to mole. Liters oxygen cancel. I need to put of O2 in the next fraction at the bottom, and then I can go from moles to molecules because we've been doing this for a while. 1 mole of oxygen would have Avogadro's number, or 6.02 times 10 to the 23rd molecules in it. So moles of O2 cancel. And my calculator is 1800 and ... like a lot of other digits times 10 to the 23rd. Oops. Okay, so none of this matters for sig figs. This has 2, so I get to keep the 1 and 8. There's 0 after, so that's just going to keep it at 1.8. 1.8 times 10 to the 23rd. Right here's the rest of it. Molecules, O2. Okay, I have quite a few practice problems for you at this point because I want you to be able to repeat this enough times that you get the hang of it, and that if you are messing up, that you can fix your mistakes. You have the answers on the paper for that matter right there. But a lot of people become so used to, using the answers to tell them that they do it right, that they don't even know what to do once the answers are removed. So what would help is maybe if you cover up your answers and don't look at those and then check them after you get them. That way you have a better judge of whether or not you know what to do on your own. If you need me during this, like if you, despite all of your attempts and rewatching this video if necessary, cannot come up with the answer on the paper, then please let me know. And we can have a conference outside of regular office hours if necessary, or if I can help you in words, I'll help you there. All right, get that practice turned in.